is differentiation by substitution? Why it is required? It is required just to solve difficult problems in physics, in derivatives. Derivative has wide application in many chapters of physics. It is required for that. We learn a rule that is called chain rule of differentiation. So we are going to learn chain rule of differentiation. Suppose there is a function like, say, y equal to, by any calculation you got this thing, x cubed plus 2. You got this. Then how do you find derivative? You know derivative of sine x, but you don't know derivative of sine of x cubed plus 2. You cannot write that derivative is cos of x cubed plus 2. No, yes. That is not true. To find the derivative of this kind of function, what we'll do, we'll make a substitution. We'll write or y equal to sine z, where you assume z equal to x cubed plus 2. This will simplify our calculation. That's why this substitution. Y equal to sine z, z equal to x cubed plus 2. So you find derivative. Differentiating first one, y is a function of z. So you'll be differentiating with respect to z. Okay?
Yes.
When you write dy by dx, you have differentiated function of y with respect to x. Here we'll differentiate y with respect to z. So dy by dz will be cos z. Okay? Because sin x derivative is cos x, it is just variable is changed. Z, it will be cos z. From here, you find differentiating with respect to x. What will I get? dz by dx. This is going to be 3x squared plus derivative of 2 is 0. So now we can multiply these two. And that rule of multiplication is actually chain rule. Okay? When you have replaced a part of the function by another variable, then this rule we have to apply. The chain rule states that our dy by dx in the problem will be dy by dz multiplied by dz by dx, as if z and z getting cancelled. dz getting cancelled, dy by dx is remaining. What is dy dz? Just to substitute. It is cos z. What is dz dx? It is 3x squared. So there it will be cos of x cubed plus 2 into 3x squared. So it's a huge sum. Its derivative we have done by chain rule, going to be 3x squared cos of x cubed plus 2 dy by dx. Clear?
Yes.
So this is dy by dx. If we say that no, I don't need all these things, I'll do it by, because the step we have done here, it is clear to me. I'll be finding by different method. If I don't write it, because I'm doing it for the sake of physics, why all these things, big calculations should I do? If I remember this, that for a big function like this, to find dy by dx, we imagine that only sin x is there.
Yes.
Only sine x is there. What is derivative of sine x? Cos x. So
Yes.
I'll write that. Okay, you are saying it is x cube plus 2. Its derivative I multiply. Won't I get the same thing what you got here?
Yes.
So it is cos of x cube plus 2, 3x square plus 0. Answer is 3x square cos x cube plus 2. See how nicely it's coming? This is
Yes.
also chain rule. But we did some calculation mentally. I did not write what is chain rule. I mean, this step I did not show in calculation. Any function, if it is big one, another variable required, then also we will apply this thing. Okay? Let me apply another sum here. Suppose I am doing it for this example. Y equal to root over 3x plus 7. Example 1, I have to find its dy by dx. If you use chain rule, okay, I don't have any problem. You can do. If you say that I can do mentally, proceed, no problem. Mentally means that method. Here you write y equal to 3x plus 7 to the power half. If you go by formal method, you write let y equal to z to the power half, z is equal to 3x plus 7. We write dy by dz, half z to the power minus half. And then we write dz dx, which is 3. So I can find dy by dz. And sorry, dy by dx I can find now. And this is going to be dy by dz into. So this will be half. Answer is 3 by 2. 3 by 2 z to the power minus half. That is 3x plus 7. Clear to you? Understand?
Yes.
I've just done it by using chain rule. But if I don't want to use chain rule, then you can write a let no. Here no let is there. Nothing being letting. Here just we do it mentally. The dy by dx will be, imagine no 3x plus 7 is there. It is x to the power n form. X to the power half. You write this as half 3x plus 7 to the power half minus 1
Yes.
into its derivative.
Yes.
X derivative is 1 and derivative of 7 is 0. So it will be 3 by 2 minus half. Answer is 3 by 2 under root 3x plus 7. Finished. Okay?
Yes. Yes.
So this way, by chain rule, it can be done. Let me show you a few more sums. Then I'll give you a set of 2-3 sums to practice. Or we'll go for direct application. It depends on you. If you say that I can manage it, it's fine. So let us find derivative of this thing, the third example. Say, in any problem we found, it is sine cube x. It is y equal to 1 by root 4 minus x square, or another one. From my side, it is y equal to x by root over x square plus 4. You will often meet this kind of problem in physics. So how to find dy by dx? And that by chain rule, and that by observation. I'm doing all by observation. If you say that I need to do it by using the traditional method, by assuming z, all those things, I definitely do. Let us do this one first. Just imagine it is y equal to sin x whole cube. Okay, something like x cube. X cube derivative is what? 3x square. So you
Yes.
write differentiating with respect to x. dy by dx will be 3 sin x to the power 2, like x cube, 3x square, into sin x derivative. So final answer you got. Okay, this is done. Derivative of sin cube x. And for this one, if y equal to 4 minus x squared to the power minus half, right, this is appropriate. Because this is nothing but, if you rewrite, this is 1 by 4 minus x squared to the power half. This goes up, minus half. So now differentiating with respect to x. dy by dx will be minus half 4 minus x squared to the power minus half minus 1 into its derivative 0 minus 2x. So if you just cancel it, it is going to be x by 4 minus x squared to the power 3 by 2. Finished?
Yes.
Not a difficult one at all. Just remember basic formula. Then it is done.
Yes.
So for x by root x square plus 4, what to do? This one bit difficult than previous ones. But if you remember chain rule, it's not a problem at all. It is x by x square plus 4 to the power half. So differentiating with respect to x, dy by dx equal to denominator whole square, half square, it is 1. X square plus 4 to the power half, derivative of x, x into derivative of, am I clear? It's all right.
Yes. Yes.
Now we can use differentiation rule. First one, as it is, no derivative sign. It will be x square plus 4 to the power half. Derivative of this is 1. X into half minus 1 and 2x plus 0, that divide by, now need to simplify it. Sum is done. Sum we have completed. So this is root x square plus 4 minus half minus 1 is minus half.
Yes.
I hope this indices concept you have. X
Yes.
square plus 4 to the power minus half.
Yes.
This is 1 by root x square plus 4. So x square by 2 to get cancelled. And this is root x square plus 4 by, so to add and simplify, this is root over this, root over this. If they are multiplied, so the result going to be 4 by 1 plus half, that is 3 by 2. This is the value of x by root over x square plus 4 to the power half, derivative of that function. Okay. So
Yes.
another problem, if I take, say, which arise in next chapter, maybe, I mean, no, in which chapter this kind of equation is there. Y equal to sine of 3 sine of 4x minus 5. Find dy by dx. This is simple harmonic motion equation. That type, you have to find dy by dx for this. Simple, same manner we'll be doing. Like we write differentiating with respect to x, dy by dx will be 3. 3 is constant. It is d dx of this thing. Sine of 4x minus 5. It is sine derivative is what? Cos into derivative of this thing to be multiplied. 4. That is 12 into cos of 4x minus 5. Clear?
Yes.
Now practice few sums on this kind of thing. Find dy by dx for y equal to x root over x square plus 2. Number 2, y equal to 5 cos 7x plus 8. And number 3, y equal to 2x plus 1 by x cube plus 3. Just do these 3.
Yes.
Just practice. So application of differentiation in physics. Part 1 also I have written. Why? Because this time we'll find application, just straightforward application. Just by differentiating how to get the answer. Mostly kinematic sums are involved in part 1. But part 2 means their concept of maximum minimum will arise. Okay? It's a long process for understanding. But for application, you can do it in moment if you understand all these things. So let us start with one simple problem here, like this. This sum. I have problem 1 and 2, but those sums are substandard, very easy. I did not do. But before applying the sum, you just read the statement. Particle moves along straight line with position function given by this. Find the velocity acceleration function of the particle. So how to use calculus? Those basic formula you need to use. that is in terms of derivative only. That displacement we normally take in physics as x or s. Suppose you are taking displacement as the quantity s. S is a function of t, so you can write this manner. Or x is a function of t, you can write this manner. This kind of problem, if you compare with your class 9-10 problems, maximum you have seen this kind. A is equal to ut plus half at square plus 7, 8, 9, all these things are dominating. But t square is okay. If tq arise, then we cannot compare with this equation. We cannot find acceleration velocity. And this equation will represent some curve where point to point velocity, acceleration, all are changing. So we need the concept of instantaneous velocity and acceleration. So to solve first one, it is given displacement function. I've set this function because this problem, it matches with the concept of function in physics. Displacement is a function of t, that's why it is st. You can simply write s. S equal to 2 cube this plus 4t plus 1. Velocity. If I remember this definition, dy by dx, it is rate of change of y with respect to x. And when I'm telling you velocity is not uniform, you have to use instantaneous one. That is ds by dt. This symbol stands for velocity in our calculation. So long you will study physics, it is there. The ds dt stands for velocity. Okay. Now, if velocity is ds by dt, what is the expression for acceleration? Instantaneous. This is instantaneous velocity. And derivative of this dv by dt, this is called instantaneous acceleration dv by dt. Okay.
Yes.
Now acceleration will denote by a. I have another form, that's why I'm writing this. Acceleration dv by dt or dv by ds into ds by dt. That chain rule I'm applying here. As if ds get cancelled. So you can write a equal to ds by dt is what just we've seen v. Acceleration has another expression v dv by ds. So acceleration can be done by using this formula, that is instantaneous acceleration. Acceleration can be done by this formula, that is also instantaneous acceleration. So which formula? It depends on the demand of the situation. Depending on the demand, we'll be going by this one acceleration or this one for acceleration. Okay, let us go back to the problem given here, that particle moves along straight line whose displacement function is this, velocity and acceleration of the particle. To find velocity, we'll be using this formula. So differentiating with respect to t, ds by dt will be t dt of 2t cube so this is nothing but 2 comes outside d dt of t square 4 dt of t, and this one constant, its value will be 0. So 3t square, it will be 6t square minus 12t plus 4. So you got velocity as function of time. 6t square minus 12t plus 4. So velocity function we got. Acceleration function, how will I get? If I got velocity, then acceleration is dv by dt. So you differentiate this function. We have v equal to, okay, so differentiating it will be derivative of this 6 into 2t minus 12 plus 0. So dv by dt equal to 12t minus 12. Here, acceleration is a function of time t. I am adding something to this problem. Suppose they have asked you, after what time velocity will be positive? Or when the velocity was negative, which when the particle moving along straight line, if velocity along the direction of displacement, we know that velocity positive. But it may be negative also. Particle going towards right. Particle going towards right. Can it have velocity towards left? Particle going towards right. Can it have acceleration towards left? All these things are questions of physics that I discuss when I discuss the theory. Here, if they ask you for what time acceleration is positive and when it was negative, your answer will be this is for acceleration. So acceleration positive means 12t minus 12 greater than 0, t is greater than 1. So this time acceleration is positive. Acceleration negative under what condition? If t less than 1. It's like this. Questions are like this. Kinematics problem can be of any form, but in kinematics, normally they give equations like this. More difficult question may be there. Let us see the second one. This one, the time interval in which particle is moving in the positive direction. This is same thing, that particle moving and that displacement will be greater than 0. It is mathematical. I am giving you one physics question, right? Displacement of a particle is given by x equal to 20 plus t cube minus 12t. Question is find x, v and a when t equal to 0. Another one, state whether it's moving with uniform acceleration or not. And the third question, find its position when v equal to 0. You have to find the position when v is equal to 0. This is a physics problem. You can get this kind of problem. How to answer? Find x, b, and a when t equal to 0. So let us write the expression for all three. X. X is what? You write it is 20t, 20 plus t cube. So differentiating dx by dt will be 20 derivative is 0, 3t square minus 12. Therefore, v equal to 3t square minus 4. Now acceleration will be what? A equal to dv by dt, the expression we have seen before. 3 is a constant, it will be there, derivative of this thing. 60. Now, let us find x, b, and a when t equal to 0. It's very easy. You just use these three expressions for x. When t equal to 0, when t equal to 0, x we are getting 20 plus 0 minus 0, 20. When t equal to 0, velocity is what? 3 into 0 minus 4, that is minus 12. Minus 12 means what? Velocity is negative. Particle going towards right, it is going towards left. So velocity is negative. And when t equal to 0, acceleration is equal to 0. Clear?
Yes.
By differentiation, we get all these things. Now the second part, state whether it is moving with uniform acceleration or not. What is the value of acceleration we got? We got this thing, a equal to 60.
Yes.
So a is proportional to t.
Yes.
So a is time independent. As a is a function, I mean variable function. If it is constant function, okay. But it is variable function. It is function of time. So a is not uniform. Clear?
Yes.
A is not uniform. Then number 3. Find its position when b equal to 0. This is interesting. This question is calculus mathematics based question. Find position when b equal to 0. B is the expression you have to take. This you cannot do without calculus. You can do, but it will take long step. So position when b equal to 0. What you'll do here, you'll find when, what time velocity is 0. And that value of time you get, you'll put there. This is the requirement. So for the third part, as this implies 3 into t equal to plus minus 2. But t is not negative in our calculation. It can never be that. So we'll take t equal to 2. Time to velocity 0. So what is the displacement that time? That you can get here by putting By putting into the expression, you can get displacement. So, position of the particle x2. x2 means at t equal to, for the expression of t, you put 2. It is 20 plus 8 minus 24. That is 4 meter. Okay?
Yes.
So position x2, which is equal to 4 meter. Clear?
Yes.
Solve another problem here. Just another problem. Let us solve on it. This is a challenging question. Huh? This is a bit challenging. This kind of question, I hope you have understood, but
Yes.
this one is a bit challenging. But this, I remember I set in DPS paper when I was in DPS. This same question. Okay. So let us
Yes.
do a relation between time t and displacement. Relation between t and displacement s is given by, or x you write, and x is given by t equal to ax square plus bx, where a, b are constants. Okay? Find the retardation of the particle. Find the, author said retardation will be there, so we'll assume retardation is there. Find retardation. Maybe acceleration or retardation. Let's see what happens. This question not similar to previous 2-3 questions. Bit difficult. Okay? Because if x is given as function of t, we differentiate. Dx by dt is the velocity. Then differentiate again. You will get the acceleration. Problem is t given in terms of x here. Although x is a function of t, but they have done this thing. So what you have to do, which mathematical technique you will apply, let me tell you. You keep it this way. Given t equal to, so differentiating with respect to x, dt by dx we get derivative of ax square plus b, we have to write 2ax plus b. Understood? Just
Yes.
differentiate, similar, no difference. Just differentiate it with respect to x. But we need what? We need dv by dt. We need ddt of dx by dt, which is a mathematical form, d square x by dt square. This is called second derivative. Okay, ddt of dx by dt, symbolic presentation is d square x. We need this. But we got dt by dx. What to do? We just take reciprocal. Take this one on left side or right side. Therefore, dx by dt, which is reciprocal of dt dx, is 1 by 2x plus b. This is dx by dt. This is v. So v equal to dx by dt equal to this thing. Okay?
Okay.
Now we have to find acceleration. So differentiate with respect to t. dv by dt going to be d dt of 1 by 2ax plus b. Okay?
Yes.
Acceleration, dv by dt we got. But then there is a problem. Right side is function of x. We are differentiating with respect to t. How is it possible? We manipulate chain rule there. See, I'm writing here in this form. D dx of 1 by 2x plus b into dx by dt. If you accept, then it's fine. Otherwise, we'll stop here. We have used chain rule only. We have
Yes.
taken dx here, multiplied by this. There is no problem. Dx has get cancelled. So what is the advantage here? We got acceleration A. This derivative we know. Change, I mean that quotient rule we can apply. Or you write one more step. I'm showing you another way. Sometimes students prefer to do this manner. You write d dx of 2ax plus b to the power minus 1. And dx by dt we got earlier. No, that value we'll put there. 1 by
Yes.
2ax plus b. So what is its derivative? Minus 1, 2x plus b to the power minus 2 into derivative of this thing 2a into 1 by 2x plus b. So minus 2a by, clear? That's
Yes.
why they are talking about retardation. We got minus sign here. So it is minus 2a into velocity we got here. Same expression I got here. Can't I write 2a v cube? So therefore, acceleration. Achha, this you write in the form of acceleration because a is there on right side. You write this as acceleration only. Okay, so acceleration equal to minus 2a v cube. As acceleration is negative.
Thank you.
So for this line, if you have drawn perpendicular AL and BM respectively, then this length distance from origin is x1, this part is y1. And similarly, distance of this point from origin this part is x2. Put of perpendicular is at a distance x2 from the origin. This length is x2. And this total length is y2. This is y1 means this part is y1. So this length BR going to be y2 minus y1 and this is x2 minus x1. The slope of tangent tan theta we also can write as BR by AR, which is nothing but y2 minus y1 that divided by x2 minus x1. This is slope of tangent. Okay. Slope of tangent is given by this relation. Now the problem arises if we want to define slope of tangent to a curve. There is a curve. It has some equation. Curve may represent anything. Ellipse, parabola, hyperbola, many curves are there. We need not know. But if there is a curve, then is it possible to define slope of the curve? No, not possible. At a particular point, the tangent makes some angle. We can define the slope of tangent to the curve at a particular point. Suppose they are intersecting at this point. This angle tan theta if you have drawn perpendicular, if you have drawn a tangent, then this tan theta is equal to slope of tangent PT drawn at the point P to the curve. Curve is y equal to fx. Any curve. It can represent any curve. Then tan theta is slope of tangent PT drawn to the curve at the point P to the curve. Our problem is to get the value of this tan theta. This we have drawn to the curve. But we want to get this value of tan theta, I mean slope or m, whatever you say, in terms of quantities given in the curve only. Suppose this point is at hk. We want to get slope of tangent, just not in terms of tan theta. That tan theta we want to get in terms of hk. But how to get? So let us do it in general. I mean, for the curve, the same curve, when we are taking, we'll be taking 2 points on it. Okay, let me draw in, let me get it in different diagram. This curve is there. This is the curve. We want to find the slope of tangent drawn to the curve at this particular point, okay, P. So for this purpose, we assume that coordinate of this point on the curve be x comma y. Take another point on the curve, that is x plus delta x, y plus delta y. This is the origin. We want to find tangent of this in terms of xy, or if it is hk, in terms of hk. We have taken a point close to the point, not close, just another point pq. Now, if you join these 2 points, there is a chord pq. This you can see that chord pq is there. This is the chord pq. Now, this chord PQ obviously not coinciding with the tangent drawn at P, but it can coincide if we take the point Q very close to P. Okay, let us do some drawing here. Draw a perpendicular here. Just a perpendicular PL is drawn. Another perpendicular you draw here. This is QM. For the sake of calculation, we are doing all these things, QM. And from here, draw another perpendicular, PR. Okay. Obviously, triangle Q, and in this triangle PQR, in triangle QPR, this angle is not equal to this angle. Okay.
Yes.
Now, what we are making, or we take this angle in triangle QPR, let us take, let angle QPR is equal to phi. We assume that this angle is equal to phi, this angle, phi. Tan phi is what? That we can do easily. This part is x. This one x plus delta x. So this part delta x, this is also delta x. This part y, this part y, this part is delta y. So in triangle PQR, we can write this thing also. That is tan phi is equal to delta y by delta x. This is quite obvious. Perpendicular by base. Now, you are making this PQ gradually. We are writing PQ. Or do one thing. Assume that Q is very close to P. Let us make let Q is tending to P. Q tending to P means it is going very close to P. It means that is delta x is tending to 0. There is no x coordinate difference there. If this one comes here, you will say why not y coordinate also tending to 0? Definitely, but y depend on x. So if I say that delta x is very small, delta y is also very small. So let q tending to p, that is delta x tending to 0. Under this condition, angle QPR is tending to angle this QPR, QPR tending to angle this QPR tending to with this angle theta equal to phi, angle PTR, that is phi tending to be equal to theta. See now, if Q is tending to P, then PQ is becoming gradually getting inclined to the tangent PT. When Q is very, very close, this chord PQ and arc PQ has no difference, isn't it? Chord PQ coincide with arc PQ. So phi is tending to theta. So in this case, therefore, in this case, limit delta x tending to 0, delta y by delta x. When it is tending to 0, this ratio will be, instead of tan phi, we can write tan theta. Same thing. Theta is going to be very close to it. Phi is tending to be very close to theta. So limit delta x tending to 0, delta y by delta x going to be equal to tan theta. But this thing we have learned. This is dy by dx. dy by dx going to be equal to tan theta. Under what condition? When q is tending to p. What is tan theta? Slope of tangent drawn at the point P. So this slope of tangent is actually dy by dx. This is called geometrical interpretation of the derivative. Therefore, dy by dx at P is equal to slope of tangent at P. This is a very, very important term. This method will help you to understand how do I approach instantaneous velocity from the average velocity. Say average velocity delta, if we consider the graph of x versus t, average velocity will be delta x by delta t. You replace delta y by delta x and delta x by delta t. Okay, so let me explain that method. Why you are doing, you must know that why it is required in physics suddenly. Why geometrical interpretation of dy by dx equal to tan theta? It's a problem actually facing by many students of class 11 physics. When we say average velocity, particle going in a curve, okay, obviously this will not be This will not be y in terms of x. Instead, displacement will be in terms of time. So we'll be drawing x versus t graph. Now in this x versus t graph, if we plot x versus t graph as a curve like this, then suppose particle goes from this point to this point, A to B, along this curve where x is a function of t. Okay? Then if you draw this arc, you can do it. To draw this arc AB, AB is the arc here. Obviously, chord AB and arc AB are not coincident. If you draw tangent here at this point, this is the tangent at the point A. It is the tangent. This point has coordinate, assume this point has coordinate t, x. This one has coordinate t plus delta t, x plus delta x. Just draw a perpendicular here, the same manner, AL. Draw another perpendicular, BM here. This is the perpendicular. Why perpendiculars are drawing? Let me explain. Because the same manner, this is slope of tangent, tan theta. This one is phi. Phi is angle BAR. Now, if this one is t, this part delta t, and this is x, this part x, this part delta x, this part delta t. So, when the particle goes from A to B, suppose a particle is in motion. When a particle goes from A to B, goes from the point A to the point B, then average velocity is equal to displacement. It's a vector quantity that divided by delta t. I'm avoiding vector now because just motion in one dimension we're considering. Vector we need not consider. AB by delta t. AB is the displacement that you understand from the graph. This is nothing but delta x by delta t. So average velocity we have defined. Is it possible to define velocity at the point A, velocity at the point B, velocity at any arbitrary point P on the curve? For that, what we need to do, we'll assume that B is gradually tending towards, suppose this point we have taken T A, so this point I am taking T A S. Okay, when B tending to A, then BA tending to what? SA. SA coincident what? With what? AT. SA coincident with AT. So in that case, chord AB or BA being coincident with AT. Under this condition means what condition? B is close to A. That is delta t tending to 0. Delta t can be tending to 0. Who told you that AB will be always a very large quantity? AB may be any quantity, but when B is very close to A, delta t tending to 0, this ratio delta x by delta t, sorry, this is delta t, delta x by delta t, that limit tending to 0, just a minute. limit delta t tending to 0, delta x by delta t, dx by dt, this is equal to instantaneous velocity. So geometrical interpretation of dx by dt now going to be slope of tangent, which is nothing but instantaneous velocity at a point. This is true for xt graph, displacement time graph. If it happens in velocity time graph, it's a curve, then that will represent the rate of change of velocity, which is nothing but instantaneous acceleration. Hope we have understood the geometrical application of derivative, isn't it?
Yes.